Hello guys, welcome to Ramta Solutions and welcome to lesson on 12 momentum and impulse. Today in your past paper series, we're looking at a past paper from Mpumalanga 2022's preparatory exams. So your September 2022 from... Okay, so let's read. A bullet moves 560 meters per second west. It hits a wooden block with a mass of 3 kilograms. And you see something. So I'm going to say velocity of the bullet. I'm going to call the bullet 1. What is it? Initial. Okay. 1 initial is 560 meters per second west. Okay. It hits a wooden block with a mass of 3 kilograms. So I'm going to call the block 2, which has a mass rather of 3 kilograms. It is moving at 2.5 meters per second east. So initial velocity of the block, which is v2I, is 2.5 meters per second east. Of course, on a frictionless flow, the bullet takes 0.02 seconds to move through the wooden block. So delta T of collision, delta T of collision is 0.02 seconds to move through the wooden block with a velocity of 80 meters per second. Okay, so final velocity of the bullet is 80 meters per second where? East, right? They said east. The magnitude of the momentum of the bullet before it hits the block is 8.4. So P1 initial is 8.4 kilogram meter per second. They said the magnitude. So direction, so ignore the effect of air friction as well as any loss of mass. Assume the system is an isolated system. You guys recall what is an isolated system? It's a system in which the resultant force is 0. Okay, perfect. Now, question 1. Explain the meaning of the term isolated system. What is an isolated system? It is a system, let's see. It is a system in which the resultant force is 0. In which the resultant force, is right? Perfect. Question 2, Roman figure 1 says, calculate the mass of the bullet. We're given initial momentum. This will help us. And we also have initial speed or velocity, right? So I will take it as speed because we only need mass, which is a scalar quantity. So whereas the momentum, they said it was 8.4. What is the mass? We do not know. What is the speed or velocity? It's 560 meters per second, right? West, of course. So what is our mass? It's 8.4 divided by 560. What does it give you? It gives us 0.05 kilograms. Okay. Guys, you can also round it off to 2 decimal places, but for the sake of convenience, just leave it as it is 0.015, okay? At least later on you will realize that we're talking significant figures, okay? So leave it as 0.015. I think it makes more sense because it says this is basically 15 grams. Okay, perfect. Number 2, the speed of the block after the bullet. The speed of the block after the bullet left the block. Okay, so what is it? or after the bullet struck the block. Whichever it is, there's a mistake here, but it's okay. So what is this? We'll say, I will choose east as positive. Okay, I prefer east being positive, so I will choose east being positive. Even if you choose west positive, it's okay. So this is M1 V1 V1 initial plus M2 V2 initial equals M1 V1 final plus M2 V2 final. This part was given to us, but notice, guys, momentum is a product of mass and velocity. The velocity was 560 meters per second west, and we said east is positive. So you know that mass times velocity, it will be negative. So we are given this part. We don't have to substitute. We don't have to substitute its mass and its velocity. All right. We are given this. They said it was 8.4. So we will say it's negative 8.4. Now this we can substitute. It is 3 kilograms. Initial velocity was 2.5 going east. So it will be positive 2.5. Now final velocity 0.015. What is the final velocity? It was 80 but west, so it will be negative 80 plus 3 V2F. Okay, so this is negative 8.4. 3 times 2.5. This one, I think it's 7.5. I don't need to use a calculator for this. Now, 0.015 times 80. Okay, I just calculated the 0.015. So on my calculator, I'll just answer times 80. This is negative 1.2 plus 3 V2F. Now, negative 8.4 plus 7.5 plus 1.2 is equal to 3 V2F. What is this? Negative 8.5. No. Hold on. 8.4 plus 8.7. This is 0.3. I don't want to waste my battery, guys. Please bear with me. Okay, so yes, let me confirm. Negative 8.4 plus 7.5 plus 1.2. What is it? It's positive 0.3. Therefore, this tells you that V2F is 0.1 meter per second. Pay attention. The question was saying you must calculate speed, not velocity. But since you can see that this is basically positive, it's supposed to mean that velocity is eastwards, right? It is. Okay. All right. Now, let's go to the third question. Roman figure 3 says the average net force on the block, the average net force the block exerted on the bullet during the collision. Guys, something that you should know is this. At the end of the day, you know the block is going to the left, right? Sorry, to the right or eastwards, and the bullet is going to the left. So whichever answer you get, make sure that eventually it makes sense to you. Okay, let's try this. I will try F net. Okay, I will try this F net delta T equals M V F minus V I. Okay, again, you must say if this is positive. It's important because these are vector calculations. I don't like this thing of squeezing, so let me just begin with this. F net delta T equals M into V sub F minus V sub I close. I'm choosing east being positive. Okay, so I'm going to take properties of maybe the block. Okay, the block. Let me take the block. So I'm going to leave this as F net delta T. Oh no, we're given delta T because it was the collision time was 0.02 seconds. So 0.02 seconds What is the mass? The mass is of the block. It's 3. What is the final velocity of the block? It was 0.1 meters per second to the east, right? Because we said east is positive, so it's east, and we're saying east is positive, so it will be 0.1 minus initial velocity of the block. What was it? It was 2.5 east, so I'm just gonna say minus 2.5 then. Okay, so let's see. Okay, let me just do it like this. 0.02 F net. Okay, so here we're referring to, I'm using information of the block. Okay, so this F net is the F net that the block experiences. Okay, is the F net that the block experiences. So let's see. 3 times negative 0.4, negative 2.4, not 0.4, negative 2.4. Okay, negative 2.4. Okay, what is it? It is negative 7.2. So this negative 7.2 divided by 0.02 is 360. So F net is negative 360. Right? So it's negative 360. So this F net is 360 Newton west, right? Because we said east is positive. But then we're saying the average net force the block exerted on the bullet during the collision. If we using Newton's third law of motion, we can see the block is going to the right, and I'm saying this is the net force that the block experiences. Therefore, F net that the block provides, or that the block provides to what is this, to the bullet, or that the block exerts to the bullet, is 360 newtons east. As you can see, you expect this to be east. So guys, pay attention to this part here. This F net is basically one that is experienced by the block, not the one that the block exerts. Okay, this is one that is experienced by the block, not the one that the block exerts. The one that the block exerts, as you can see, the block is moving rightwards, must be rightwards. Okay. So, with that being said, it's a wrap, guys. Let's see. For this question, you're supposed to be getting 5 and 6, 11 marks. So, these 11 marks are yours. So, I hope you ace such questions. Okay. So, bye-bye.